Hello, I'm Dr. Maria Belengarte, and I'm going to talk to you about enzymes. Okay, so now we're going to talk about characteristics. An enzyme is a protein molecule that is a biological catalyst with three characteristics. First, the basic function of an enzyme is to increase the rate of a reaction. Most cellular reactions occur about 1 million times faster than they would in the absence of an enzyme. Second, most enzymes act specifically with only one reactant, called a substrate, to produce products. The third and most remarkable characteristic is that enzymes are regulated from a state of low activity to high activity and vice versa. Enzyme isolation. Much of the information about enzymes has been made possible because they can be isolated from cells and made to work in a test tube environment. Extensive work has also been done with X-ray diffraction techniques to elucidate the three-dimensional structure of some enzymes. The ribbon and backbone form of carboxypeptidase is shown on the left. The substrate is shown in magenta. Enzyme parts. The activity of an enzyme depends, at the minimum, on a specific protein chain. In many cases, the enzyme consists of the protein and a combination of one or more parts called cofactors. This enzyme complex is usually simply referred to as the enzyme. Apoenzyme. The polypeptide or protein part of the enzyme is called the apoenzyme and may be inactive in its original synthesized structure. The inactive form of the apoenzyme is known as a proenzyme or zymogen. The proenzyme may contain several extra amino acids in the protein which are removed and allows the final specific tertiary structure to be formed before it is activated as an apoenzyme. Cofactor. A cofactor is a non-protein substance which may be organic and called a coenzyme. The coenzyme is often derived from a vitamin with specific examples discussed later. Another type of cofactor is an inorganic metal ion called a metal ion activator. The inorganic metal ions may be bonded through coordinate covalent bonds. The major reason for the nutritional requirements for minerals is to supply such metal ions as zinc, magnesium, manganese, iron, copper, potassium, and sodium for use in enzymes as cofactors. Final enzyme. The type of association between the cofactor and the apoenzymes varies. In some cases, the bonds are rather loose and both come together only during the course of a reaction. In other cases, they are firmly bound together by covalent bonds. The activating role of a cofactor is to either activate the protein by changing its geometric shape or by actually participating in the overall reaction. The overall enzyme contains a specific geometric shape called the active site, where the reaction takes place. The molecule acted upon is called the substrate. Enzyme nomenclature and classification. Enzymes are commonly named by adding a suffix "ase" to the root name of the substrate molecule it's acting upon. For example, lipase catalyzes the hydrolysis of a lipid triglyceride. Sucrase catalyzes the hydrolysis of sucrose into glucose and fructose. A few enzymes discovered before this naming system was devised are known by common names. Examples are pepsin, trypsin, and chymotrypsin, which catalyzes the hydrolysis of proteins. The latest systematic nomenclature system, known as the International Enzyme Commission System, is based upon the type of reaction catalyzed. There are 6 broad groups of enzymes in this system, which are named in the graph below. Okay, so that was all, and thanks for watching.